So section 1.2 of chapter 1 is all about solving linear equations in one variable. And the key word here for us is that this is in one variable. So that means they're only going to have one variable in it. So you're going to be given equations, and the standard form for equations, linear equations in one variable, look like this. Ax plus b is equal to c. A, b, and c, these are all real numbers. So I use the funny symbol for r. That's the real number symbol. And the only, the x part is your variable. And the only restraint here is that a is not allowed to be 0. Because what if a was 0? What would we have? Yeah, exactly. There'd be no x. Yep. Yeah, no big deal, right? So standard form, that's what they look like in one variable. So what do we do with linear equations in one variable? Well, one thing that we do all the time is we solve equations. So what does it mean to solve equations? What does it actually mean? In your own words, what do you think? Yeah. Find out what the variable is. Find out what the value of the variable is. Good. So let me give you 2 examples here. We'll do A and we'll do B. A, 7x plus 2 is equal to 0. That one looks pretty straightforward. Let's do B. Let's do 6 times x minus 1 plus 4 is 3 times 7x plus 1. All right. Which one looks easier? The first one. Let's do the first one. Okay, I'm with you. Somebody help me out. What do I do first? Yeah, we're going to use inverse operations, right? The inverse of addition is subtraction, so we're going to subtract 2. So that leaves me with 7x is equal to how much? Negative 2, right? 0 plus the negative 2 is nothing. Is negative 2. Divide by what now? Well, now, why am I dividing? Isolate the variable. It's the inverse of multiplication, right? So divide 7 both sides. So I get x is equal to negative 2/7. Hey, that's okay. X doesn't always have to be like 2 or 5 or 3, right? X can be a funky number like that, like negative 2/7. No problem. Don't hate. It's all good. All right. How about part B here? I have to do something. What should I do first for part B? Yeah, distribute. Good. So some people call it the rainbow method, right? So 6 times x is 6x. 6 times negative 1 is negative 6, yeah? Plus 4, let's see here, 3 times 7x, how much? 21x, good. 3 times positive 1, how much? All right, so check it out. I've got x's on both sides of my equal sign there. What do? Subtract 6x? Okay, I'm with you. Could I have done something else? Or I could have, yeah. So it doesn't matter, right? Doesn't matter. So on the left-hand side, I have negative 6 plus 4. How much is that? Negative 2 equals 21. Take away 6. How much? 15x. Good. Positive 3. Now what? Man, you guys are all over this. No problem. So negative 5 is equal to 15x. Last step. What am I going for here? Divide by 15. Look at this, man. We're going to simplify. So I'm getting negative 1/3. Is that what you're getting? Yeah. Sweet. Negative 1/3. All right. So I'm assuming that everyone in the room is pretty good at solving equations, yeah? Okay, good. Let's try a more challenging one then. What do you say? Yeah, that's the spirit. I love it. Like, yeah, let's try it. Bring it on. Okay, example. Let's do this. Let's do x over 3 plus 3x over 4 is equal to 2. All right. What makes this more challenging? Fractions. All right, no big deal. All right, what do we do to get rid of these fractions? Where do you get 12 from? Is Amy, right? Where do you get 12 from? I don't see a 12 anywhere on the page. Where do you get 12 from? Okay, good. So we take 3, we take 4. 12 is the first number they both go into. We're going to use that, okay? So check this out. I'm going to multiply the entire thing by 12, all right? This is going to get rid of my fractions, and here's why. When I take 12 and I multiply it by x over 3, so I'll do this on the side, right? 12, if I multiply this by x over 3, can't I just say 12 divided by 3 is 4, right? And then 4 times x is how much? 4x. So literally this whole piece just drops down and becomes a 4x. Nice. Very nice. You with me on that? Let's do the same trick to this next one. So 12 times 3x over 4. Let's see here. 12 divided by 4 is 3. 3 times the 3x, how much? Yeah, so let's make this all the same color. So I'm at positive 9x equals, this is the easy one, 2 12s is how much? 24. Awesome. 9 and 4. So 13x's is 24. Now what do? Divide by 13. Divide by 13. Good. I'm getting x is 24/13. You can leave it as an improper fraction. You don't need to change it to a mixed number. Hey, that's cool, right? That's a number. It's out there. It's fair. It's okay that it looks funky, right? All right. How do you feel so far? Pretty good? Okay, we got 10 minutes left, and I want to talk about problems that have extraneous solutions. All right, sometimes in mathematics, we come up with answers that don't exactly fit the mold for the problem. So let me give you an example of what I'm talking about. So let's say we're trying to find, solve for x in 1 over x minus 2 equals a 3 over x plus 2 minus a 6x over x squared minus 4. All right, before we even begin, we're trying to solve an equation in one variable. The variable is x, but notice that I have fractions. And what do you always have to be careful of when you're dealing with fractions in mathematics? No, what can you never divide by? 0. Okay, good. So you have to ask yourself, is there a number out there in the world that would make this fraction 0 on the bottom? 2. Where do you get 2 from? 2 minus 2, right? So in this one, we can't let x is not allowed to be a 2. If it was, then I get 1 over bad, and that's not good, right? Is there another number out there? Negative 2, and that comes from this one right here, right? So this one, x is not allowed to be a negative 2. So right off the bat, I want to keep in my brain that x is not allowed to be plus or minus 2, right? Positive 2 or negative 2. So I want to hold that up in my brain while I'm doing this problem. You guys okay with that part? All right, so now I'm going to go ahead and solve for this, all right? I'm going to go ahead and solve. Now, what do I need to do first in order to solve for this? Yeah. So I'm going to have 1 over x minus 2 equals 3 over x plus 2 minus 6x. I'm going to factor this into the difference of two squares, which is x plus 2, x minus 2. So notice that this whole piece has now been factored into that whole piece down below for the difference of two squares. So far, so good? Good. What's the LCD here? Good. So we're going to multiply the whole thing by x plus 2 times x minus 2. All right? And here's what's going to happen. When I multiply this times the first piece, I get, notice what part goes away? The x minus 2. So all I'm left with is the x plus 2. Very good. X plus 2 equals, let's see here, when I multiply this times this term, what part goes away? The x plus 2. So I'm left with a 3 times an x minus 2. And then what happens when I multiply? They all go away. So what am I left with? Just a 6x. Wow, that looks a lot easier to deal with than the top part, don't you think? I think so too. So I've got an x plus 2 equals, use the distributive property, 3x minus 6 minus a 6x. You with me? All right. I have variables all over the map. I have a variable here, I have a variable here, and I have a variable here. What should I do now? Simplify. Very good. All right, so I've got x plus 2 equals, let's see here. Is that negative 3x minus 6? Yeah? Is that true? Yeah. Okay, so I'm getting 4x is now equal to negative 8 when I do two more operations. You still with me? Yeah. Okay. Divide by 4. So I'm getting that x is now equal to negative 2. Awesome, sweet. I did the problem. I'm stoked. Yes. Harrison, what do you think, dude?
You made it a negative 3x.
What did I do wrong?
It goes from 3x to -3x.
Yeah, because I got 3x take away 6x. So, yeah, what's up?
Well, -2 can't be an answer since there's x plus 2.
Yeah, shoot. I got an answer of x equals -2, and it was one of the ones that I could not get. So, this one, we say has no solution. So you will, from time to time, come across problems that have no solutions. You actually get an answer, but the answer is extraneous, which means it doesn't fit the mold of the problem that we're doing right then and there. Does that make a lot of sense? So last part, try x over 5 minus x over 2